What would happen if Earth suddenly stopped spinning? Would we be thrown across the planet at over 1,000 kilometers per hour? Would oceans swallow continents? Could humanity survive even a single day? It sounds like science fiction, but the physics behind this question is very real, and the answer is far more terrifying than most people imagine. How fast is Earth actually moving? Right now, as you sit still watching this, you are moving at incredible speed. At the equator, Earth spins at about 1,670 kilometers per hour. That's faster than most commercial airplanes, yet we don't feel it. Why? Because everything around us, the ground, the oceans, the atmosphere, is moving with us at exactly the same speed. This shared motion creates stability, but that stability depends on one thing: continuous rotation. Has Earth ever slowed down before? Before we imagine it stopping, we need to understand something important. Earth is already slowing down, very slowly. Due to gravitational interaction with the Moon, a process called tidal friction, Earth's rotation decreases by about 1.7 milliseconds per century. That may sound insignificant, but 400 million years ago, a year on Earth had roughly 400 days instead of 365. Geologists know this from coral fossils. Ancient corals grew daily rings, like tree rings, and preserved a record of how many days existed in a year. This is not speculation, it's physical evidence that Earth's rotation changes over time. The Moon is slowly stealing our rotational energy, and it is moving away from Earth at about 3.8 centimeters per year. Earth is not static, it is dynamic. But what if that slowing didn't take millions of years? What if it happened instantly? If Earth suddenly stopped spinning, instantly, everything not anchored to bedrock would continue moving because of inertia. At the equator, that means objects would continue moving east at 1,670 kilometers per hour. Buildings would shear off foundations, vehicles, trees, oceans, everything would surge forward. The atmosphere would not stop either. It would continue racing around the planet at supersonic speeds. Winds exceeding 1,600 kilometers per hour would scour the surface. This would not be a storm. It would be a planetary shockwave. Most structures on Earth would not survive the first minute. Earth is not a perfect sphere. Because of rotation, it bulges at the equator. The centrifugal force pushes water outward. If rotation stopped, that outward force would vanish. Gravity would pull the equatorial water back toward the poles. The result? Massive redistribution of the oceans. Water would migrate toward polar regions, flooding vast areas of the northern and southern hemispheres. Meanwhile, areas near the equator would lose significant ocean coverage, exposing new land. The geography of Earth would change permanently. Continents would not disappear, but coastlines would shift dramatically. Would gravity change? Gravity itself would not disappear. Earth's gravitational pull is caused by its mass, not its rotation. However, rotation slightly reduces your effective weight at the equator. Without rotation, that small outward centrifugal force would vanish. You would weigh slightly more at the equator, about 0.3% more. Not enough to crush you, but measurable. What about day and night? Now imagine Earth stopped spinning, but continues orbiting the Sun. One full rotation relative to the Sun would now take one entire year. That means 6 months of continuous daylight, 6 months of continuous darkness. One side of the planet would bake under constant solar radiation. Temperatures could soar beyond survivable limits. The opposite side would freeze in prolonged night. Atmospheric circulation would attempt to balance these extremes, creating global superstorms. Climate zones, as we know them, would vanish. Agriculture would collapse. Ecosystems would destabilize. Life would face its greatest test. What about the magnetic field? Earth's magnetic field is generated by the motion of molten iron in its outer core, a process known as the geodynamo. Rotation plays a role in organizing that motion. If Earth's spin somehow stopped entirely, the internal dynamics of the core could eventually change. Over long periods, this might weaken or destabilize the magnetic field. Without a strong magnetic shield, solar radiation would directly impact the atmosphere. Over geological scales, this could strip away atmospheric particles, similar to what happened to Mars. However, this effect would not be immediate. Has anything ever changed Earth's rotation? In 2004, a massive earthquake near Sumatra, one of the strongest ever recorded, slightly altered Earth's rotation. The quake redistributed mass inside the planet. Scientists calculated that it shortened the length of a day by about 2.7 microseconds. Microseconds are tiny, but measurable. This proves that Earth's rotation is not fixed. Large-scale events can affect it. Another famous demonstration of Earth's rotation came in 1851. French physicist Léon Foucault suspended a giant pendulum in the Pantheon in Paris. As the pendulum swung, its plane of motion slowly rotated relative to the floor beneath it. But the pendulum was not turning. The Earth was. It was one of the first direct visual proofs that our planet spins. Rotation is fundamental to Earth's behavior. Is it physically possible for Earth to stop? In reality, a sudden stop is nearly impossible. The amount of angular momentum Earth possesses is enormous. To halt its rotation instantly would require energy comparable to a planetary collision, something like a Mars-sized object striking Earth. And if that happened, stopping rotation would be the least of our concerns. The impact alone would likely sterilize the surface. What if it slowed gradually? If Earth slowed over millions of years instead of seconds, life might adapt. Coastlines would slowly shift, climate systems would evolve, species would migrate. Human society depends on predictable 24-hour cycles. Our biology, circadian rhythms, evolved with rotation.